In this video, you can learn how to prepare nanomaterials by co-precipitation method. In co-precipitation process, the required metal cations from a common medium are co-precipitated generally as hydroxide, carbonates, oxalates or citrates. These precipitates are subsequently calcinated at appropriate temperatures to yield the final nanopowder. This method is also known as soft chemical method because the process temperature is always less than 100 degrees Celsius. In this method, the structure, morphology and the composition of a nanomaterials can be controlled in a better way if each reaction step is appropriately controlled. The working conditions like stirring speed, vibration, exposure to light and cleanliness of glassware can significantly affect the quality of nanomaterials formed. The pH of the solution is one of the critical parameters which decide the phase formation, particle size and morphology. This flowchart shows the various steps involved in nanomaterials preparation by co-precipitation method. Firstly, to get precursor solution, the host precursor materials are dissolved in the solvent to get the starting solution. Generally, deionized water, ethanol, methanol and isopropyl alcohol are used as solvents. Then, doping of our interest is achieved by adding required amount of the dopant precursor to the starting solution. The pH of the solution is one of the critical parameters which decide the phase formation, particle size and morphology. Therefore, required amount of complexing agent like ammonium hydroxide, KOH or sodium hydroxide and ammonia solution is added to maintain the appropriate pH value of the starting solution. The resultant mixture is heated at a desired temperature between 60 and 90 degrees Celsius and magnetically stirred for a suitable period of time. The precipitate formed is separated out carefully by filtration and washed several times thoroughly with a mixture of suitable ratio of ethanol and water. The product is then dried in an oven at a particular temperature for a period of time ranging 2 to 3 hours, and then the obtained powder is finally calcinated at desired temperature and then allowed to cool to attain room temperature to get a final nano product. This is the schematic diagram of co-precipitation process. Using magnetic stirrer, a stirring process can be done. After stirring, the mixture is allowed to cool at room temperature. By filtration, the precipitate is separated out. The separated particles are allowed to dry with the help of oven. The dried products are allowed for calcination process at desired temperature. After calcination, you can get a final product. This co-precipitation method has some advantages. These advantages are, it is a simple direct process for the synthesis of fine metal oxide nanopowders. Homogeneous mixing of reactants precipitate reduces the reaction temperature. This method has some disadvantages. They are, this process is not suitable for the preparation of high, pure, accurate stoichiometric phase. This method does not work well if the reactants have non-compatible solubility values and different precipitate rate. Experimental conditions are not universal in the synthesis of various types of metal oxides. Hope you have learned how to prepare nanomaterials using co-precipitation method. Thank you.